Hi everyone. We got section 1.4, computer logic networks in discrete math. And what we'll see is these are very much like our truth tables that we had, but computers use 1 and 0. 1 is for true, and that turns a switch on in the computer program. 0 is for false, and that turns a switch off. Now, with computer logic networks, there are 3 basic gates: not, and or. And these are the symbols that they'll use symbolically a lot for those. Now, if you have input for P is 1 and 0, the output, if you go through this gate, turns a 1 into a 0, and it turns a 0 into a 1. It's not P. So, remember what we had before. And the ands, if you have 2 conditions here, P and Q, just like the trues and false, we have an input and output table. These are your 4 possibilities. 1 and 1 will give us an output of 1, true. 1 and 0, 0 and 1, and 0 and 0. These are zeros. It's just like 1s are trues, 2s are false, or 0s are falses. Now, the or, notice the symbol here for or. I'll set up with the same inputs here for P and Q. And then the output, P or Q. 1 and 1 make 1, 1 and 0 make 1, 0 and 1 make 1, 0 and 0 make 0. It's just like it was for true and false. Alright, I got just one more example for you to look at. I want you to look at this network that's right here. You've got P and Q, and then you have a not. So what you're really talking about is you figure out what P and Q are right here, and then you negate it. Okay, now let's set up the 1s, 1 0, 0 1, 0 0 as possible inputs. And then let's look at the P and Q. And then 1 and 1 make 1, 1 and 0 is 0, 0 and 1 is 0, 0 and 0 is 0. And then, when you get your final output, after you go through this, it's got to go through the not. So your final output will be a 1 turns into a 0 turns into 1, 0 turns into 1, 0 turns into 1. Now guys, that's all I have for you right now. We'll do a couple more examples when we start in class, and then we'll work from the book tomorrow. But for now, just get that down, understand the basics of it, and we'll take off running with it tomorrow.